Hey guys, welcome back to AP Simplified. Today we're going to be covering the rest of Unit 3, which is the procedure for calculating derivatives and calculating higher order derivatives. So by the end of this video, you should be able to identify which rules of differentiation you will need to differentiate a formula and in which order. You will also be able to calculate higher order derivatives. Okay, let's start by jumping right into our first problem. So here's our first problem. It's asking us to differentiate y is equal to e to the raised to the power of x cosine x. So the first thing I want you to do is identify which rules of differentiation you would need to use in order to solve this problem. So I'll give you a second to pause the video and find that out. Okay, hopefully you realize that the rules of differentiation you will need are the chain rule and the product rule. Now you might be asking, in which order should I do it? Should I do chain rule first or product rule first? So in this case, you would do chain rule first because, as you remember, e raised to the power of anything is just going to be e raised to that power. So you want to treat this as the outer function, e raised to the power of x cosine x. You want to treat that as the entire function. And then the function within the function, if we're speaking in terms of chain rule, would be x cosine x. And that's where you would use the product rule. Okay, so if we apply chain rule, first we'll find the derivative of the outer function, which is the entire thing, which is easy. It's just itself, because e raised to the power of anything, it's just going to be e raised to that power. So then we multiply that by the inner function. The inner function is going to be this one right here. And as you can see, the inner function, you actually need product rule in order to differentiate that. So we use product rule, and this is what we get. We get e raised to the power of x cosine x times x times negative sine x plus cosine x times 1. You can get rid of that 1. So let's simplify a bit. This should be your final answer right here. It states that y prime is equal to e raised to the power of x cosine x times cosine of x minus x sine x. And like I said before, all I did was simplify here, and this should be your final answer. Okay, so that was a brief synopsis of how you should go about differentiating. So now we move on to calculating higher order derivatives. So right here is the notation that you'll see. There's multiple ways to ask to find the derivative. Some of the most popular ones are y prime and f of x. You should be familiar with all of these. They pretty much mean the same exact thing. Now you'll find that once you are asked to find the second derivative, the third derivative, and so on, the notation changes a bit, but it's pretty much the same. So for y prime, you just keep adding a prime until you go up to the third derivative, and then from then on, you just add the number. So if you want to find the fourth derivative of the function some function y, then the notation would be y to the 4. Moving on, the same thing applies for f of x and pretty much all of the other notations. You should be familiar with all of these, but once you get the first derivative down, the rest are pretty simple to follow. So here's our second problem. It's asking us to find the second derivative of y is equal to the cosine of x plus e raised to the power of 3x. Okay, so the first thing we want to do here is to find the first derivative, because essentially the second derivative is just the derivative of the first derivative. Now, I know that sounds extremely complicated, but it's really not. Let's just start off this problem with finding the first derivative, which we know how to do very well. Okay, so I just rewrote the function here. Okay, so let's start off with, let's start finding the derivative. So, of course, the derivative of cosine of x is negative sine x, and here we would apply chain rule. So, outer function, derivative of that is e to the 3x, and then the inner function's 3x the derivative of 3x is 3, so this is what you should turn out with. If we simplify it a bit, bring this 3 up here, the final answer should be negative sine x plus 3x, or sorry, negative sine x plus 3e raised to the power of 3x. Okay, so now that we have our answer here, we're not done yet. We found the first derivative, so in order to find the second derivative, we have to find the derivative of this function, right? Okay, so all we have to do is find the derivative of this. So let's start doing that. Okay, so the derivative of negative sine x is negative cosine x plus, so the derivative of 3 e raised to the power of 3x is very similar to what we had before. This time all we have is a coefficient of 3 out front. So we apply chain rule the same way. So the outer function, if we take the derivative of that, it's going to be the same thing. And then the derivative of the inner function is going to be 3. So if we clean this up a bit, you get negative cosine x plus 9 e raised to the power of 3x. Okay, finally for our last problem, we're going to be taking the second derivative again. The only thing that changes here is that we're going to be using a little bit of implicit differentiation. So let me show you what I mean by that. If x squared plus y squared is equal to 25, what is the value of d squared y over dx squared at the point 2, 1? So as you can see, this is just one of our many notations for the second derivative. So it's asking to find the second derivative. So let's first start off by finding the first derivative. So right here, you should be able to recognize that we have to use implicit differentiation. So let's do that. Okay, so you should find that the derivative of x squared is 2x, of course, and then plus the derivative of y squared, which is 2y prime. Now, you might use another notation. However, I like y prime because it's just easier to visualize. So this is not simplified yet, so we have to simplify it in terms of y. So once you do some simplifying, you should find that y prime is equal to negative x over y. Okay, so we found our first derivative. Now we need to go about finding our second derivative, which is just the derivative of this. Okay, before we move on, there's actually a little shortcut you can do that'll make your life a little bit easier. So, if we plug the coordinates of this point in right here, you should get -2, because of course, if you plug it in, it's going to be -2 over 1, which is -2. And that'll make finding the second derivative a lot easier, because actually, let's move on to finding the second derivative. So, the second derivative, like I said before, is just the derivative of this. So, if we were to apply quotient rule, we would get something that looks like this. Now, if I didn't have access to this point right here, this 2, 1, I would have to plug in negative x over y into the equation here, and I would get a huge mess, and all I would be able to do at that point is simplify. But since we have that point, and we know that y prime is equal to -2, we can actually go about plugging in -2 into this y prime, and we can also plug in the other points. We can also plug in the points themselves. So if you plug everything in, including this -2, you should get something that looks like this, which is 1 minus 2 times -2 over 1 squared. If you simplify this, you should get 5. So essentially, it asks us for the derivative of this equation, or the second derivative of this equation at this point, to which we responded with y double prime is equal to 5. And like I said before, this is just one notation of the second derivative. Okay, and that concludes our video for Unit 3, lessons 3.5 to 3.6. Feel free to drop a like on this video and subscribe, and I hope to see you in the next video. Bye.